friends, welcome once again. Today we are going to discuss about the Diophantine equation. If I have a number x and I want you to assign any value to it, the assigned value must be integer, and it does not matter if it is negative or positive, both goes, negative or positive. So if I allow you to put any value to x, so what values can you put? The answer is any value. You can put whatever values, whatever. So x can take on from any number in the number line, from the negative side or the positive side, whatever. But then if I give you the number 3 times x, so what values will you get? If you are allowed to put any value on x, so for 3x we will get only and only the numbers that are multiples of 3, right? Okay, so if I give you two numbers, that is x and y, and I let you to choose any number you want to put, so what will you get from x plus y? From x plus y we can create any number in the number line. We can choose x as 1 and y as 4, and then we can create a number that is 5. We can take x as minus 1 and y as minus 3, and then create the number minus 4. So it actually does not matter whatever number we can create. So we can create any number. Is it the same with 3 times x plus y? In 3 times x plus y, we can only create the multiples of 3. We cannot create whatever number. We can only create the multiples of 3, given the freedom to choose any number for x and y. Only multiples of 3. But then the same case is of 3x plus 6y. If you have this combination 3x plus 6y, what numbers can you create? So in 3x plus 6y, we can only create numbers that are multiples of 3 again, because you see that 3x plus 6y, we can write it as 3 times x plus 3y, right? And x plus 3y, you can choose any number, whatever number you take for x or whatever number you take for y. Here whatever number can be formed, and that number will always be multiplied by 3. So 3x plus 6y, we cannot create any number. But can we create 3x plus 6y equals 20? Is it possible that 3x plus 6y is equals 20 when x and y are only integers? It is not possible. It is not possible. Because 3x plus 6y, we can write it as 3 times x plus 6y equals 20. So whatever number we take inside here will always be multiplied by 3. And therefore, 3x plus 6y as a combination must be equal to something that is a multiple of 3. But 20 is not a multiple of 3. So in other words, we can say that 3x plus 6y should be equal to, here in this part must be the GCD of 3 and 6. If we take the GCD of 3 and 6, and the answer is 3. So therefore, whatever number you have here, that number must be a multiple of the GCD. If it is not a multiple of the GCD, then it is not possible. So such kind of Diophantine equations are not possible. So to solve a Diophantine equation, that is to get the integer set of solutions for a problem with two unknowns, the GCD of their coefficients must be equal to or the multiple of their results. In this case, the GCD of 3 and 6 must be a factor of the number 20. Alright, now here I have some equations, and we want to check if these equations are feasible, that is, if we can get integer solution for x and y both in these cases. So the first thing is that we must check the GCD. Now the GCD of 24 and 18 is 6. But if 6 is a factor of 19, 6 is not a factor of 19. 6 cannot be multiplied. 6 can be multiplied by 3 and that will give us 18. But then 6, if you multiply it by 4, it becomes 24. So 19 does not go into 6. So therefore we can say that this equation is not possible to be solved as a Diophantine equation. That is, we will never get a solution of x and y as integers. Let's check the next one. 2x plus 3y equals 69. The GCD of 2 and 3 is 1. So when the GCD of 2 and 3 is 1 and 69 is a factor of 1, or we can say 69 is a multiple of 1, so any number goes. So therefore 2x plus 3y is solvable. In case of the third one, GCD of 5795, the GCD is 19. So you see that 19 and 19 are the same number. So the 57x plus 95y, the coefficients, the GCD of the coefficient is 19 and the answer is 19. So therefore this one is solvable. 1035 and 585, the GCD of these two numbers is 45, and 45 is not a multiple of 901, or 901 is not a multiple of 45. So therefore the fourth equation that we have is not solvable. So that's it for the part 1. We will come back again with the techniques how to solve for x and y. Thank you so much for watching.